Heinemann Higher. Chapter 6, Differentiation. Mixed questions at the end. Exercise 6x. Question 3. Find the rate of change. Well, the rate of change is the derivative, only evaluated at a certain point. So the first one, differentiate it. It's not ready yet, because I haven't got it as coefficient x power. So I'll have to take that x up to power negative 1. Now I can do it. dy by dx is going to be multiplied by the power negative 6. Take 1 off the power, negative 2. So that means negative 6. Negative power means it should have been underneath, squared. So working out to x equals 3 simply means if x equals 3, then the derivative, which is the rate of change, would be negative 6 over, substituting that 3 in. I think I'll use a wee placeholder just to emphasise it. Not necessary. So I've got negative 6 upon 9. Negative 6 upon 9, cancelling it down, negative 2 upon 3. So the rate of change at x equals 3 is negative 2/3. Then b. So f of x equals functional notation. Not ready to go yet because I can't quite see the power there, but I've got my separate terms. So root means I've got a fractional power and it's the second root, so it'll be a 2 that's in the denominator, x to the half plus 6x. Now I can differentiate it. So I'll use the expression f dashed of x multiplied by the power. A half times 4, a half of 4 is 2. 1 off the power. It's halves, so I'll need to take away halves. 1 is 2 halves. Take away 2 from 1, that's negative 1 half. Linear term, coefficient, so that would be 6. There you go there. Now, put that back the way I found it. So negative means the x should be underneath, and that 2 in the denominator, the fractional part, means root. So it's 2 over x, the square root of x, plus 6. Then work it out at 16. I don't need to specifically say this time, because with this notation, I can just say f dashed of 16. So I can see that x has been replaced by 16. So I've got 2 over the square root of, and x has been replaced by 16, so it's a 16 that goes in here. Could put the wee placeholders if you like. Plus 6. So what's that? Square root of 16 is 4, so it's 2 over 4. 2 over 4 is a half, so it's 6.5. So the value would be 6.5. So C and D now. C, first of all, it's not ready to go. I'll need to split that up so that I could either spell it out, and since I've started I might as well finish. Both of them share the same denominator, and then either just by thinking in simple terms when it's just whole number powers, x squared cancels out x cubed leaving just an x, or in terms of indices, 3 take away 2 is 1, which I don't need to show. X would cancel out one of the x squareds underneath, one of the x's underneath leaving an x underneath, so that's 1 over x, which is x to the negative 1, or just thinking of powers, 1 take away 2 is negative 1. Now I can differentiate it. dy by dx would be, that's just a linear term, so it'll be 1. I can see the power here, negative 1 times negative 1 is plus 1 times it. Take 1 off the power, negative 2, put it back the way you found it. Negative means x is underneath, and that 2 is a whole number, so it's a power. And then evaluate it at negative 2. So I'll have to say, at x equals negative 2, that means dy by dx would be 1 plus 1 over, and it's a negative 2 being squared. It's even more important here to use the little placeholder for the substitution, so that little negative doesn't escape out of the squaring process. So I've got 1 plus 1 over, negative 2 times negative 2 is 4, 1.25, which you can write as 1.25, or if you have a particular preference, 5 upon 4, but I'm going to stick with 1.25, not knowing what needs to be done with the next. D. That's quite a simple one. Not ready to go though, because I've not got the x up on top and I can't quite clearly see its power. So the x going up on top would mean it was underneath, so it's got a negative power, it's got a root, so it's got a fraction, it's power 1 and it's root 2. But you can soon get familiar with the square root, so you automatically know the square root is power 1/2, underneath negative 1/2. Now it's fit to differentiate. So differentiate, multiply by the power, 3 times 1/2 will just be 3 upon 2, so it's 3 upon 2x. 1 off the power, it's halves, so take away 2 halves, that'll be negative 3 upon 2. So what does that lot mean? Well, that power's got nothing to do with the 3 and the 2. The 3's on top, the 2's underneath. That's your coefficient. So it's negative 3 over 2. It's the x that's going to go underneath. The fractional part's the root, so it's the square root of it. The top part of the numerator is the power. The neatest way is to write the square root of x cubed. The alternative would be the square root of x and then cube it, which is in fact the way you would work it out. It's just neater to write it that way. Then it says what? So what's the value x equals 9? Well, I can just use that notation since it's got that little holder there. So evaluated at 9 means I've got negative 3 upon 2, the square root of, and I'll write 9 cubed. But when I work it out, I'm going to do the square root first, then the cubing. Square root of 9, 3. 3 cubed, 27. So I've got 3 over 2 times 27. 3 into the 27 goes 9, so there's only one left on top. 2 times 9, 18. So my final answer is negative an 18th. Maybe we should have underlined those wee bits first of all, because that was the first part of the problem, to arrive at the expression for the rate of change and then evaluate it at those particular points. Right, that's question 3.